All right, let's talk now about the different types of chemical reactions that we're going to look at in chemistry. The first type is a synthesis reaction. Now, if you know anything about the term synthesis, then you might know that something is being put together. So what I'm going to do is I'm going to give you kind of a little code to use for each of these as far as looking at reactants and products and what's happening with these reactants and products. When you have a synthesis reaction, you have usually two reactants, at least, that are then combined to make one. Okay, so in a situation, you might have two different gases coming together to make another gas or even make a solid or a liquid. Okay, you also have the opposite, which is decomposition, in which case you have a single reactant that breaks down into two or more products. Okay, so notice how these two are opposite or complementary equations or types of reactions. The third type is called single replacement. In this case, you've got an element as a reactant and a compound as a reactant, so something that's made up of more than one element. And what happens is they undergo a little switcheroo where now A is going to bond with C rather than B bonding with C. Keep in mind that typically this is going to be a metal that is going to take the place of the metal that is in this compound. So now instead of having A and then BC, you're going to have AC bonded and then B is all by itself. Okay. We'll also have something called double replacement. In this case, you've got two compounds and they both switch partners. Now, in this case, you really need to be aware that A is not going to bond with C. Remember that the first atom or ion in a compound is always the cation, so you're not going to have this cation bonding with this cation. You're going to have A bonding with D, and then you're going to have C as the cation bonding with B. Okay, so you really need to keep in mind the sequence for each of these compounds. And remember that the first thing in every compound is always going to be the cation. Well, in ionic equations anyway. The last type of equation or reaction is a combustion reaction. In this case, what you're going to have every time is AB plus O2. It's that O2 that means this is a combustion reaction, and it's always going to result in some CO2 and H2O. There might be some other compounds as well, but you've always got CO2 and H2O. These are the 5 types of reactions. You do need to be able to identify each of them. Now, on your reference pages, you have this section here, which is here to help you predict products for the different types of reactions. Okay, so for example, when you have a synthesis reaction, it gives you some ideas. Just like the code that I gave you, A plus B makes AB. Now keep in mind, if this is an ionic compound, you also have to figure out what the subscripts are in case they have different valence numbers or different oxidation states. With decomposition, the major one that we're going to look at is the first one, binary compounds splitting into single compounds. Single replacement, typically we have metal-metal replacements or halide-halide replacements, which we're going to look at both of those. So in class, what I'm going to show you is a way to determine whether a replacement actually even occurs. And this only applies to single replacement, but sometimes a compound is very stable. Let's say BC here is very stable, and A is not strong enough to take the place of B here. And I will show you how we determine whether A is tough enough to steal B away from C in this scenario. Same thing for halide-halide replacement. I'll show you how to determine which ones are strong enough, tough enough to actually take out or replace a partnered pair already. Double replacement, we're going to do some additional work with double replacement equations because frequently what happens is a precipitate is formed, and when a precipitate is formed, that means that a solid is formed. But that doesn't happen in every scenario, so I'm going to show you again how to use your reference pages to figure out whether a precipitate has formed. And again, we'll also do plenty of practice in order for you to get used to double replacement equations. And again, with combustion reaction, it's always going to be combining with oxygen, producing carbon dioxide and water. Here it says it's always a hydrocarbon, meaning hydrogens and carbons. However, you'll see some additional examples, if we have time to get to them, of things that are not just hydrocarbons, but also undergoing combustion reactions and producing some additional products. Okay, so again, a quick review. These are the specific ones that you will need to know how to use and reference. So combustion and double replacement. But those are the major ones that we will be talking about in class, and those are the major ones that you will be assessed on.